Hello everyone, here are the answers to 1 through 13 from worksheet 6.1 I assigned yesterday, so please take a look at them. 1 through 5 is on this page. These are all just coming from our notes so far. Pause the video if you still need more time to check these. And then here we're just using the calculator. Again, make sure that you sketch. I didn't include those here, but make sure you include the sketch of the standard normal distribution with the z-value plotted and the area shaded. And let me know if you have any questions on those. All right, so we're continuing with section 6.1, but now we're going to take a look at the standard normal distribution as a probability distribution curve. So as I was kind of mentioning, when we have the area under the curve, it could be thought of as the probability as well. So a normal distribution curve can be used as a probability distribution curve for normally distributed variables. Whereas in chapter 5, we were looking at a discrete distribution. Now we're looking at a continuous distribution. For every z value on the x-axis, there is a corresponding height or frequency value. All right, so another way, we're still pretty much doing the same calculation as yesterday, but it's another way to look at this. So as I just mentioned, the area under the standard normal distribution curve can also be thought of as probability. But yesterday we were asked this first way, find the area between z equals 1.68 and z equals negative 1.37. Now, it could just be stated like this. Find the probability that a z-score is going to fall between these two values. And we already did the sketch yesterday. But again, we would just go back to menu 552, type in the lower boundary, then in the upper boundary, and get that 0.868. All right, so I want you guys to try these next 3 examples. Again, instead of us being asked to find the area under the curve, to the left or to the right or between certain z values, now it's the probabilities here. So pause the video, go ahead and calculate those 3. Now it's still good to make a sketch as well, so if you haven't done that, please go back and do that. A good visual always helps. So for A, we're looking at 0, between 0 and about 2.32. And we should be getting about 0.489. And hopefully this makes sense because 50% is to the right of 0, and we don't have that full half, that entire upper half shaded in, so does it make sense that it should be less than 50%? Yes. All right, for B, we're looking at all of the area to the left of 1.65. So we should be getting a 0.951. And then our third, we're looking at a 1.91. We're going to the right. That's a small little section there, so we should be expecting a small area or percentage here. We're getting about a 0.028. All right, so just more practice with using the feature on our calculator. But now we're going to switch things around. Sometimes we have to find a specific z value for a given area under the curve. So here we're going to work backwards. So now what we're going to use is menu 553 on our calculator. It should be labeled as the inverse normal. One thing to note here, the area we're typing in, the calculator is always going to read it as to the left of the z-score. So we have to kind of be smarter than the calculator here and know exactly what to type in. And if our answers make sense. All right, so as we go to menu 553, we need to type in the 98.26% as a decimal. So we're typing in 0.9826 for the area, and that's all we have to type in. Notice again, mu is 0, standard deviation, sigma is 1. So we should be getting a 2.11. We're always going to round just to 2 decimal places. So z is going to equal a 2.11. And if that makes sense, let's go ahead and make a little sketch here. So if we're looking at like a 2.11, and we're seeing all of this is the area that's shaded, yes, that makes sense that that would be correspond to 98.26%, so that would be correct. Let's take a look at number 2. All right, now we're to the right of z, so this is going to make a little bit of a difference. Still go ahead and go to menu 553, type in 0.3859, and go down to OK. There's really 2 ways we could think of this. So what we're getting now, if we used 0.3859, we're getting z is equal to a negative 0.29. So if we go to sketch this, we're looking at right here like a negative 0.29. What the calculator is showing is that this is the area to the left. So that's what we typed in and we got this. But we want to say that this is to the right. So isn't this bell-shaped curve, the standard normal distribution, symmetrical with respect to the mean? So all we'd have to do in our case is just flip it around. So this would be our positive 0.29. And then this area over here would be 38.59%. So that's one way to do that. So therefore, to answer our question, but again, this is to the left, we have to make sure that this percent is to the right. So that means z would equal a 0.29. Or what we could do is if we said that 38.59% is to the right, all we'd have to do is 1 minus the 0.3859, and that would be the area to the left. So if we tried that, that would be 61.41% is left of our z value. And then you can use this 0.6141 as our area. So let's try that. 0.6141, after we go to menu 553. And we're getting the positive. So there's 2 ways to do this. You could type in this percent, but know that the calculator is reading it as to the left. And then all you have to do is flip it to the other side because it's symmetric with respect to the mean. Or you could just do 1 or 100 minus this percent, And then that would give us the complement that's over here, and you could just type that in. But either way, we're looking for a positive 0.29. All right, now let's take a look at number 3. 21.23% of the area under the curve is between 0 and z. So let's start by making a sketch first. Now, if I have 0 coming first here, that means z is going to be somewhere over here. If I said z and 0, that means my z would be to the left of 0. So one thing that's going to help us out, we need to know, I'm going to kind of look at this as two sections. So if this portion right here, that's the 21.23%. And then over here, this is why we talked about this yesterday, this would be what? 50%. So really this means 71.23% is to the left of z. And then we can go from there. We would know that we would just type in 0.7123 into our calculator. And we should be getting 0.56. So we have to understand the area that we're putting in. Sometimes a sketch is necessary to do first. If not, we try to find the z value, then we can maybe make a sketch and see if that's the correct z value we're looking at, or if we need to do a couple other calculations. All right, so go ahead now and finish worksheet 6.1.